Okay, section 6.4. Hey, look, it's still there. It's been a while too. So for section 6.4, we have to talk about special parallelograms. And the three special parallelograms we're going to talk about today are rectangles, rhombuses, and squares. And we're going to start off with the absolute definition of those special parallelograms. So the definition of a rectangle is a parallelogram with right angles. So remember, you have a definitions page and you have a postulates corollary page. We're going to distinguish between the two so you know what to put on which page. So a rectangle is a parallelogram, because that's what that symbol is, with four right angles. It doesn't matter. As long as it meets this definition, it is a rectangle. Same thing for a rhombus. A rhombus is a parallelogram with four congruent sides. That's its definition. It cannot be a rhombus without having those things. A square is a parallelogram with four right angles and four congruent sides. It has to have both. And yes, that does mean that every rectangle, not every rectangle is a square, but every square must be a rectangle because it's got that part of the rectangle in it. And every square must be a rhombus because it's got that rhombus part in it. Now, that takes care of the definitions, of which I'm pretty sure you already knew, but we're going to move on. Brings us to the postulate end of things, which is mostly dealing with the diagonals. Diagonals are those special quadrilaterals. So the diagonals have things that they have to have. In a rectangle, you have to have congruent diagonals. In a rhombus, you have to have perpendicular diagonals. In a square, you're going to have both, because every square is a rhombus, is a rectangle. So it's going to have both. Now, there was one in there that said that it bisects angles if it is a rhombus. And if it's part of a rhombus, and since every square is a rhombus, that means that it's going to have to bisect angles here too. It's just the way it all works. Every attribute that a rhombus has to show up in a square. Every attribute that a rectangle has to show up in a square. So the square is going to end up having them all. Now, it was not a part of the corollary or postulate or anything in the book that that's the case. But I guarantee you there'll be a problem where they're going to ask you to prove that's the case somewhere in the book. Not that I'm going to make you do that. I'm just telling you the facts right now. Okay, the other fact that I found like super interesting. I mean, super interesting, because I never knew this. So I learned something new today. The other fact was this one, about the midpoint of a hypotenuse is equidistant from all the vertices of that triangle. That's something I never knew. I found it very interesting, but I can also promise you that since it's something that I never knew, it's probably nothing you're ever really going to have to remember. Sorry. But it's true nonetheless, and quite interesting to me. So I might like throw it on test just because I think it's cool. Which brings us to, now that I've gone over all the other information, which I'm pretty sure you already understand, brings us to classwork for today, which is this, which I'm going to go over before you leave. Well, before you cut off the video completely, how about that? Before I leave. But I need for you to pause and work on it and see what you get. So it says, given that parallelogram FCDE is a rhombus, so I'm telling you it's a rhombus, and CD is 10 and FD is 16, I want you to find 1, 2, 3, 4, 5, and 6. 1 is AB, 2 is AF, 3 is ED, 4 is AC, 5 is the perimeter of FCDE, and 6 is the area of triangle ACD. So see what you can do with that. Go ahead. No, you pause it and take care of it. I don't need to pause. This is all you. I'm ready. Are you ready? I'm ready. Okay. We're going to do this. So, they tell me that this whole side is 10, and CB is the same as BD. That must mean that this is 5 and that's 5. Sorry, I like to label my picture before I do any of the answers. Just bear with me a second. And then they eventually ask about AB. They did say that this was a rhombus, right? And we learned that rhombuses have perpendicular diagonals. So this must be a 90-degree angle, which means they're all 90-degree angles. That means it's late. You should be done with this by now. They're all 90-degree angles. I told you it was a rhombus, and if that side's 10, that means that this side is 10, and this is 10, and that's 10. Okay. I told you that FD was 16. We know that this angle has to be congruent to that angle. And up here, this angle has to be congruent to that angle. Huh. It is a parallelogram. So since it's a parallelogram, if I call that a parallel side and this a parallel side and that a transversal, that means that that angle is congruent to this angle down here. Stand to reason that that must be congruent to that. And since that side is 10 and this side is 10, by angle side angle, they must be congruent, which means that this must be congruent to this. And they said the whole thing was 16, so one of them must be 8. Man, I'm getting somewhere now. Feeling good. So that's 8. That means that this side over here is 8. And I've got an 8 and a 10. And 8 tell me nothing about that. I'm going to have to work on that in my head in a bit. Okay. Given that it's a rhombus, that CD is 10 and FD is 16. I think I've got everything up there that I need to have up there. Find AB. Well, we just had this that said if it was the midpoint of the hypotenuse, and since this has to be a right angle, that must be the hypotenuse. The midpoint of the hypotenuse is equidistant from all the vertices. Well, that one's 5 and that one's 5, so this one must be 5. I like it. Okay. So AB has to equal 5. AF, ooh, we just got that one. That one was 8. ED, that's over here. Write that one down as 10. AC, oh, that's that one. Well, I hate to do this to you because I don't know if you remember it or not, but I know you've had it before. So it is a right triangle. That is the opposite side. Use Pythagorean theorem. A squared plus B squared is equal to C squared. 10 has to be my C. A can be 8. That gives me 64 plus B squared is equal to 100. B squared has to equal 36. B must equal 6. Ta-da! So they both must be 6, because remember it's congruent triangles. In fact, we got 4 different congruent triangles. Works. I'm okay with that. They want the perimeter of the whole thing. That one was pretty easy. It was 40. Then they want the area of ACD. That's this one that we started out with. Area is 1/2 base times height. But to be a base and a height, you have to, absolutely have to make sure that there is a right angle in between them in order to get your base and height. So here, my base and height would be the 8 and the 6. So that's going to give me 1/2 times 8 times 6. Half of 8 is 4. 4 times 6 is 24. That's going to be 24. Oh, look, you can't see it. Hold on. Got it. So that's going to be 24. Now, I gave you challenging work. Mediocre challenging work. A little challenging, I thought, which is good. Your homework, however, I don't think it's quite that challenging. Personally, I picked easy homework for you. So this was the classwork, which means you are done with classwork. Yay! Now all you have to worry about is the homework. It is located on page 236. It is numbers 3, 5, 7, 9, and 10. Math problems. You can handle it. Yeah, I know. But all the answers really are in the back of the book. Doesn't look like it, but they are. And after the homework, you won't have to see this again until the next time you do math.